a lot of what we do to do statistics means we have to have stuff to do statistics on. I need some data. So the question is, what is it? How do we get it? What kind of data is there? How do we classify the data before we even start doing any sort of analysis or getting any information? So data collection. Data consists of a set of observations. An observation is a single member of a collection of things. Now, this can be all sorts of different information depending on what we're doing. Within these observations, you could have many different characteristics. So a variable is a characteristic of the individual observation. The collection of you in this room, there are a lot of things I can ask each of you, that I'm allowed to ask each of you, that you could answer, that data information I already have. I've got your names. I've got your student ID numbers. I've got your email addresses. If I dig hard enough, I've got your home address, your home phone number, your preferred name. What else is in that advising pile information? I got a lot of them. So that is the data I have access to. In the pile of stuff I have all of these variables, all of these observations. I've got all this stuff. What am I going to do with it? A spreadsheet is a data set. Page 23, table 2.1. It's like this. I've got 8 observations. Each individual row consists of a person. I have their name, their age, their salary, their position, whether or not they're a veteran, and what their highest degree earned is. So I've got 1, 2, 3, 4, 5 different variables about each person. I've got 8 observations. Here's my data set. This is multivariate, multiple variables data. Got a bunch of different variables. For the most part, I'm going to start with univariate data, one variable. Larger data sets with multivariate data can be cross-referenced and broken down. There are all sorts of other relations. That's going to be more of what we do next semester in quantitative analysis. But we'll get as far as maybe bivariate data, 2 variables. For the most part, we're going to deal with univariate data. So really, most of the time, maybe I'm only looking at salary. Maybe I'm only looking at position. Maybe I'm only looking at whether or not they're a veteran or what their education level is. But I'm only looking at one of these columns for the moment. But then each individual variable has some different properties. Whether or not you're a veteran, it's a yes, no question. What your highest education is, well, there are a bunch of options there. Age and salary are numbers. Position is a description, right? As a matter of fact, within that list of positions, do any 2 people in this list have the same position? They're all different. So is that information out of this data set? That might actually not be very useful information to me. But the types of things I can do with my data depend on the type of data I've got. There's really just two adjectives here. I'm either looking at numbers or I'm not. Categorical data, categories. Words instead of numbers. So our positions, our highest level of education achieved, our veterans status, that's categorical data. Words instead of numbers. I might actually encode those into numbers. I could say on the questionnaire, are you a veteran? Click 1 for yes and 2 for no on the phone, right? 0 for no, 1 for yes. I could make it look like a number, but it's really not a number. It's just a coded version of a word. Internet radio. Pandora did this for a good long time. Pandora, you give it a song, it gives you the next one, right? You like that one. I think you'll like this one. How does it know? You should look this up. There's something called the Music Genome Project that Pandora runs. They take the song that you're listening to and write down a list of about 500 different descriptors and code each of those into a number. A lot of that data is strictly qualitative. It doesn't really mean anything. What's the genre you're listening to? Pop, rock, metal, emo? How many different categories do you want? Like 27 different varieties of speed metal. I don't know. But there's all sorts of different pieces. They put a number to them. They're almost all coded, numerical, but a lot of that data is just categorical. On the other hand, how fast is the song? Beats per minute, that's a number. I can nail that one down. That is quantitative data. Numbers, not things that are coded for numbers, but actual numbers. Now, if I'm talking about beats per minute, that's a discrete idea. Those are separate numbers. But we saw salary written on that spreadsheet of information. It could very well be that salary can be measured as precisely as you want, all the way down to the penny, right? Those are still separate categories. If I asked you for your height, how far do I take the measurement? Nearest centimeter? Nearest millimeter? We're going to measure your height to the nearest angstrom. What the hell am I doing? I go as fine as I want. That measurement is really continuous as opposed to discrete. You can take continuous data and chop it off somewhere to make it discrete, but you can't go the other way. If we're talking about beats per minute, it's very difficult to do like 237 and a quarter beats per minute. So whether we're counting distinct items, that'd be a discrete idea, or we're measuring like a length or a height, there's values in a range. That's a continuous idea. So that's my first question when I go to start looking at data is what kind of data do I have? What's the type of data I'm going to pull in from this questionnaire or this information, or what am I actually going to look for? Questions? A lot of times we see categorical data coded numerically. We rarely see, we sometimes, but not often, see numerical data coded in categories. How often do you make a phone call on your phone? Never. 1 or 2 times a week, 3 to 5 times a week. Aha, I've taken a numerical piece of information, turned it into categories, which I'm then describing qualitatively. Sometimes, never, sometimes, often, always. So there's something to be said about the way in which we measure. So let's talk about measurement. Oh, wait, before I do that, I need one other piece about the type of data. Data that gets classified as a time series is data that is collected at a different point in time for each observation. Are you present in class? Yes, no. I'm going to do that every single freaking day of the semester. So you will have a record of whether you were here when I took attendance each day through the semester, right? But that's your set of observations. So your data set times 6, right? But I know who's here today and who isn't. That's one point in time across many people, many observations. I could say, oh, I want to look at the gross domestic product. I want to look at the consumer price index. I want to look at the unemployment rate, the 10-year treasury note, treasury bill rate this morning. Those are some things that are tracked over time. I can look at an individual time, but I also look at that one item over the course of time. You own a business, revenue from sales, market share, your debt equity ratio. How many of your employees come to work on a regular basis? We're usually looking for trends and patterns over time when we look at time series. On the other hand, cross-sectional data is a snapshot. What's going on now? And then I'm looking across, my observations are all for different people or different objects or different items at a single point in time. A lot of data is done both ways and analyzed both ways. Unemployment rate. Unemployment rate gets tracked over time, but also gets tracked over state. Pennsylvania unemployment rate, California unemployment rate, Ohio unemployment rate, Florida unemployment rate. So I can take a cross-sectional look. What's the unemployment rate in each of the states of the United States today? Or I can take a time series look. What's the unemployment rate in the state of Pennsylvania for the last 20 weeks? Traffic accidents. Pick a day. What's the intersection in the city of Greensburg that had the most accidents yesterday? I don't know, maybe there weren't any accidents. I can make it bigger. Let's look at the whole United States. What is the most accident-prone intersection in the United States?
It's one in Texas. I can't remember which one.
I actually looked this one up.
The Devil's Highway?
Nope. The most accident-prone intersection, the most accident-prone traffic light in the United States is directly outside the Century Village retirement community and the hospital across the street in Delray, Florida. Because those people are so old and withered, they can't see over the freaking steering wheel. I never let my grandmother drive. Woman was shorter than the steering wheel of the car. Not happening. But then instead of looking at what is the trend over time, I'm looking for regional variation, categorical variation. Is there a set of states with high unemployment, low unemployment? Is there an intersection with the most accidents and why? Can I pin down variation among the different categories of observation in my cross-sectional data? Quite frequently, if we look at both together, we call it pooled data. like I was talking about the unemployment rate, looking at it both ways. That pooled set of data can then become something we want to know more about. All right. See if we've internalized this a bit. Page 24. Nice illustration telling me about types. Time series versus cross-section. We'll often decide on the way we want to illustrate our data based on which it is. It is rare to see cross-sectional data in this sort of fashion, because when everybody sees this, they think it's going from left to right. And so there's a kind of built-in bias that this should be a sequence of things. This is just based on the number of states that have how many bankruptcies per 1,000 person. That's just categories. So this is a cross section. This is a time series. The manufacturer of your car. Categorical or numerical? Because it's a description. Honda, BMW, whoever. Your college major. Again, we don't enumerate your majors. How many credits you're taking this semester? Aha, it's a number. Now, down here, the number of miles shown on your car's odometer. Oh, I already said the magic word. That's numerical. Same question I can ask about the number of credits. Is that discrete or continuous? Why? They're distinct, separate things. That's what discrete means. It means little pieces. I take one, I take two, I take three, I take a fixed number of things. You can take a third of a mile, right? My odometer, though, clicks over. It doesn't actually show all of those decimals, so I don't get a continuous idea. The fat grams you ate for lunch yesterday. Okay, discrete or continuous? Ah, but when I exactly say that, I'm rounding in some sense, aren't I? How many grams of fat were in that cheeseburger? Oh, 13.6. If I round off, it definitely becomes discrete, but it's probably continuous at the beginning. I can make it discrete. I can't go the other way, but probably. Good catch. The brand of cell phone you own. No numerical rate to those. Good. Okay. So now I'm taking measurements, and I have the way I take measurements. So now I have to figure out how I measure that data. Should I round off those grams of fat? What do I gain? What do I lose in that fashion? So let's talk about measurement. The lowest level of measurement, and lowest here is not meant to put this down. It is simply the most basic level of measurement, nominal data. Wait a minute, nominal, what nomen? I've heard that sound before, nomen, nominal, nominal. What's that word mean? I'm cheating. You run into crazy words, you figure out what the hell they mean by figuring out what other words that sound like that. Nomen, nomen, nomenclature, nomenclature. You have the entire internet in front of you. You don't have to stare at me like I'm a space alien. Look it up.
The devising or choosing of names for things.
Names. All we're doing is naming the data. A nominal data measurement is categories. We're naming cell phone brands. We're naming car manufacturers. I'm just naming things. So really, this is just about anything that is in categories that isn't numbers. Well, we might code them numerically, we might not. But for the most part, I'm just looking, let's color your car. I don't want you to answer. You got to red, black, gray, blue, white, fuchsia. I've seen some pink cars go by the other day. Probably have a category labeled other, right? To make a complete list. But then that's the best setup for strictly data that's nominal. If I then turn that around and say red, orange, yellow, green, blue, purple, silver, black, gray, white, turn those from the numbers from 0 to 10. Having a 9 isn't any better than having a 6. It's just a different label, right? And I could mix up the labels, change the numbers I was using. It wouldn't make a difference. I make the picture look different. It wouldn't really make a difference to the data itself. Black, brown, red, orange, yellow, blue, green, violet, gray, white. The numbers from 0 to 10, 0 to 9. Back in the pre-computer chip days, when you got little resistors, they had little bands on them to tell you what strength they were. They were color coded. 370 was 372 because it's times 10 to the second. So you get orange. Look at the colors and figure out what strength your things were. Really, when I'm doing this, this restricts the type of data analysis I can do. If I just want to know what color are the cars in the parking lot, really all I can do is count and compare frequencies. Which ones are larger, which ones are smaller, right? I really don't have a good set of math things I can do to nominal data. If all I'm getting is colors, I can't then say the average color of a car. The average color of a car, you mix all those paint colors together, you get black. Well, maybe, probably a muddy brown looking thing. Yeah. But I could ask, for some categorically ranked data. Ordinal. Again, I want another definition. What's the word ordinal mean? You're gonna get something funky related to numbers in there.
Relating to a thing's position in a series.
So ordered, ranked, put in some sort of order. This goes back to my idea of how often do you do something, right? I know a number of surveys I've taken about things on campus, customer satisfaction survey I got from the university last year. How often do you visit certain offices? How often do you go to the tutoring center? And then you'll get things like never, occasionally. I can never spell that. OCCAISONALLY. Occasionally, often, daily. Somebody tell me, what's the difference between occasionally and often? Is there a number that crosses the line there somewhere? There's no real clear division between these categories, is there? Except for this one, right? And that one. But the stuff in the middle, very squishy. Without clear divisions or what the gap is between my ranked choices, I really don't want to, again, try and do any sort of numerical calculation. Knowing what the gap is matters. But even without that, I can do some statistics that are related, instead of just to counting and frequency, to ordering. Now, the hell you mean by ordering statistics, Dr. Sassmore? Well, here's the crazy discussion that we were having over lunch today. What do you think the most liked fruit is? But again, okay, an apple. How would I go about finding this information out? Now, this is a problem, because if I just go try and find apple sales, I'm going to find apples that are sold for eating out of hand. I'm going to find apples that are sold for baking, apples that are sold for applesauce, apples that are sold for apple juice, apple cider. Oh, crap. And those are very different things. So they sell different kinds of apples, those different items, right? So now I can go through and I say, all right, I know a lot of people buy apples and go to the grocery store and just those, right? I don't know what they're using them for. I can watch the fruit selections in the cafeteria, figure out what the most popular fruit is on campus. But I could then say, this one ranks at the top, this one ranks at the bottom. But I don't know if you know, ooh, that's a strawberry level kind of fruit there. That's a banana kind of fruit there. That's a peach. That's an apple. Do these rankings mean anything? Doesn't make much sense. We'll talk about ordering statistics. Club membership, the involvement fair was earlier. Club's got to have 4 officers here at Seton Hill. President, vice president, treasurer, secretary. I got 4 names to fill in a slot, right? One above the other. Not really. On the other hand, credit rating. Bonds are issued with credit rating. AAA, AA, single A, triple B, double B, single B, and all the way down. There's not a numerical method for telling me that the gap between an A and a double A compares to the gap between a B and a double B. There's no numerical measurement there. There's a gap. I just don't know what it is. But if I do know what that gap is, well, now the distance between the rankings means something. Things like a Likert scale, right? Sometimes they're 1 to 10, sometimes they're 1 to 5, doesn't matter in particular, but you could then say, hey, the distance between a 2 and a 3 is the same as the distance between a 3 and a 4. That means something. So now I can start doing more numerical things. But there's a number missing there, isn't there? What number's not part of this list? There's no 0 up here. When we look at numerical lists that have a 0 point, that means something more. Having a 0 makes the way you do measuring different. So interval measurements aren't necessarily truly as mathematical as we want them to be. But when we think about these sorts of sliding scales, do you think you'd get better information out of a scale that looked like this or a scale that looked like this? Which one are you pointing at? The one on the left. Most of you think the one on the left? I got a no over here. Anybody else want to vote for the right one? What's the difference? There's exactly a middle, right? So if somebody really doesn't give a, they can go here. But over here, in this right-hand side, you're forcing someone to decide bad or good. There is no neutral. You're either going to come down and say, that doesn't mean that much to me, but I don't like it more than I do like it. You're forced to make a choice here. In a lot of these scales, that's actually a deliberate maneuver, whether or not you should have an odd number of choices or an even number of choices. And it makes a difference in the type of question you ask. Do I want to push you to form a decision, or do I want to allow you the chance to say, I don't care? By the way, this is coded numerically, but it really isn't necessarily numerical data. This is an opinion on how you like something, right? Might not really have a numerical meaning, but I've used this coding. We did a survey here on campus. Wow, when was Brian a student? About 15 years ago. And we asked, do you think that the president is doing a good job? That's all I want to know on a scale from 1 to 5. 1 is the president sucks. 1 is the president is amazing. What do you pick? We had 4 different versions of this survey. One went from 1 to 5. And then we took all the answers they gave us and multiplied by 2. The next version went 1 to 10. We compared those. They give us about the same answer every time. We then turned around and said, 1 means the president is amazing. 5 means the president sucks. 1 means the president is amazing. 10 means the president sucks. After doubling the one that went 1 to 5, all 4 surveys had an answer right around 6, regardless of whether 1 was good or 1 was bad. The answer was around 6. President doing a good job or not? I didn't. The survey basically told me, for most people. That's not, there's a lot of questions we can ask about this sort of interval measurement. You'll also see, if you happen to get surveys in the mail, in your email, you can also see these done as sliders. When Duquesne Light sends me an email from the power company, they have a survey attached to it. There's a little slider I can position. And sometimes it goes between the numbers. Sometimes it doesn't. What I change here when I go from interval to ratio is I have numbers that have a clear, distinct, meaningful difference between them, and I have a zero that means something. So here, the reason I want zero to mean something is the same reason we call this ratio data. Something being worth $20 is twice as valuable as something being worth $10. The ratio between the two numbers has meaning. Something having a score of 3 is not twice as good as something having a score of 1.5. But down here, when I talk about price, doubling it means something specific. 150 pounds is twice as heavy as 75 pounds. It's half as heavy as 300 pounds. So all of a sudden, the ratios matter. Interestingly enough, in spite of the fact that degrees have a meaningful zero, degrees are technically not ratio data. Is 80 degrees twice as hot as 40 degrees? What's it mean to be twice as hot? You feel twice as hot? Water boils twice as fast. Water's not boil at 80 degrees or 40 degrees, whether you're in Celsius or Fahrenheit. So we kind of get stuck when we start looking at degrees. But a lot of things that I'm going to look for the meaningful zero first, and then say, oh, that's probably ratio data. Page 27. Here is a table and a bunch of examples. Way over there, does the data have any sort of ordering to it? Color of your car. There's no real order to the colors. So that's not ordered. That's going to be name only. Nominal data. Yes, there's an order to it. All right. Are the gaps between the levels important? Do they have meaning? If no, then we're just going to order them. And there's a list of the bond ratings. AAA, AA, triple B, double B, and so forth. Yes, there's a meaningful scale. Is there a meaningful zero? If no, I get interval. If yes, I get ratio data. Number of visits to the dentist every year. Zero means something there, right? Number of children in the household. Zero means something. Likert scale. How's your food in your mess hall? Poor to good. Yeah, the numbers mean something, but zero isn't part of that, and there's no real meaning to it. Page 27. Number of hits in game 1 of the World Series. What measurement level is that at? We can actually ask two things. What type is it? And what measurement level is it? So, number of hits in game 1 of the World Series. What type, what level?
I would say it's nominal data.
Nominal.
Nominal.
Okay. So, why is it nominal?
I guess
I was going to say, you slip from one end to the other. Wait a minute. Let's talk about this.
zero means something.
Zero means something.
It does have a scale. And it is It has natural,
I've got an order, I've got a meaningful scale, I've got a meaningful zero. That pushes me all the way over to ratio data. Now, what kind of data is it? Qualitative or quantitative? Quantitative. Is it discrete or continuous? Because I'm counting the number of hits. And you can't have 1 1/3 hits. So let's take the game 1 team and pull a player out at random. What position do they play? What kind of data is that? The position of a randomly selected baseball player. Categorical. Okay, what measurement level is it? Because I don't have a ranking of this player is higher than lower than center fielder, left fielder. There's no hierarchy there that I know of, but I'm not a baseball player. The temperature on the field, start of the game. Degrees Celsius.
technically ratio, but it doesn't have a 0 that means something.
Which means it's not technically ratio.
You just said degrees is technically ratio.
Degrees fails to be ratio because the 0 doesn't have meaning the way we want it to. So really, temperature is interval. The difference between 30 and 40, the difference between 40 and 50, those match. So the gaps between things mean something. The scale is meaningful. The 0 point, 0 Celsius is where water freezes. 0 Fahrenheit? According to my history of chemistry book, 0 Fahrenheit is the coldest temperature that Dr. Fahrenheit could get by mixing salt and water. He said, this is as cold as I can make stuff. I'm going to call that 0. So unfortunately, because that doesn't have a meaningful 0, it can't be ratio. It falls out a category and becomes interval. The traffic on the freeway outside the ball field on game 1 day. How would we even ask people what was the traffic like out there?
Yeah, the ordinal data.
Because we would have an order to our answers. The traffic was light or moderate or congested or heavy, right? So there's an ordering to them that makes it ordinal data. Perfect. So you see, now that we have collections of data, we can say, oh, I've got this information. Once I know what kind of information I have, I know what I can do with it. Now, please notice, hidden in this picture here, we have above the example, we have some descriptions on things that are allowed. In our nominal data, qualitative data counting, frequency, ratios, relative frequency, did something happen more or less than something else? It's really all we can do. But in order, I can do rankings, right? And therefore I can say we had this many heavy days, light days of congestion of traffic. Once I start to do intervals, I can start doing a lot more math. There's means and standard deviations and adding and subtracting and dividing and all sorts of other math can be done here. Once I have quantitative data where the scale means something, I can start doing math to it. Once I get up to ratio data, because I have a meaningful 0, I can do lots more complicated mathematics to it, including logarithmic behavior, ratio comparisons. I can divide data because I can remove the 0 when I divide. I can do all those sorts of appropriate, crazy mathematical things. A lot of data manipulation happens more with ratio data. As I said on Monday, I want to baffle you with my bullshit. This is where I'm going to start pulling it out. Yeah. So I get data. I get to do things with it. How do I get the data? I could quite reasonably ask, what is the average age of a Seton Hill student? I've just defined the group of people I want to know about. That's the population I am going to study. Now, this could be a large group. This could be a small group. I've just given my group, my population is the entire group of Seton Hill students. But I only have 10 of you in front of me. You all are a sample of the population of Seton Hill students. But if I'm talking about age, I might actually be able to ask about every Seton Hill student. As a matter of fact, I'm sure I can get the age of every Seton Hill student if the registrar's office lets me into their computer. And that is a census. Now, I'm using census in the mathematical term here, not in the political one. Because when the government talks about a census, they are talking about the census process outlined in the Constitution. That's a different story. Mathematically, we really only have two ideas. Do I ask some small group or do I ask the whole group? Sample or census? That's it. That's all I'm after. In my case, I want to know the age, the average age of the Seton Hill student. Which would be more beneficial for me to do? A sample or a census?
Census.
Why?
Because the more data you have a complete data set in that section versus a sample size. Height doesn't depend on a small sample size. We could have four foot per people in here
Ages.
or ages.
Ages.
We could have all 18-year-olds in here, but all the 23-year-olds are down the,
Yeah, absolutely. And again, I could do that census reasonably well, right? It's not an invasive question. I probably have access to the data. A large sample or a sample sufficiently large for me to do any math with might just be pretty close to the whole population anyway. So if it's easy, I should do a census. But it then depends on whether or not I can get at the data. It might be preferable to do a sample if I had a really large population. If I asked this same question about the Penn State University system, there are 40 some odd thousand people at Penn State. I'm not going to get all of their ages anytime soon. Ask this way. When I went to the University of Florida was 42,000 people. We're not getting that information easy. What if I wanted to know whether or not your laptop would survive a 6-foot drop? Should I do a census or a sample? I'm not going to drop everybody's laptop and see which ones survive. It's destructive testing, right? So I take a couple of them and maybe run the test. We will continue discussing this idea about sampling when we get back Friday. Take a look at page 32 and 33. You'll see some of these ideas we're talking about, but there's more to come. Go have a wonderful rest of your day. See you on